Okay, for number one, it says, find the values of, find the values for m for which the roots of the are real and unequal. So I got this equation over here. I'm going to go to the whiteboard. And again, I just did the problem, but they wouldn't let me save because I ran out of space. I had to delete some files, by the way. Let's write this down again. And looking at it, again, you may not understand what you've read at this point, but you do know there's an equation there. And what you want to do is write down what the equation is. And then we'll talk about the roots of that equation. So it's 1 plus my equals 2y, and then 1 minus 2y. And I want to try to solve that. That's 2y minus 4y squared. This is 1 plus my. This is quadratic in y. What do you get over here? 4y squared. Then you're going to get plus my minus 2y, and then plus 1 equals 0. I'm going to try to write a more familiar form, 4y squared, and then I'm going to say plus m minus 2 times y plus 1 equals 0. And I'm going to get the roots. And I would do that. I'm not going to try to factor it. I'm just going to, maybe just do the quadratic formula. So y, these are the roots. And you're going to get 8 in the bottom. That's twice the coefficient of the square term. The opposite of the coefficient of the linear term, plus or minus. Let's see, the linear term's coefficient squared, minus 4 times the coefficient on the square term, times the constant, which is 1. Let's write this down again. And again, we'll read it in a moment. This will be 2 minus m, plus or minus. I got to do it inside that radicand. And I'm looking at it, and it's really just m squared minus 4m, let's see, plus 4 minus 16. And what I'm going to do is I'm going to just do the 4 minus 16, and I'm going to pull them together, and that would give you minus 12. Now this is the part where you'd say, I don't know what they want me to do. I'll go back and read it to you. It says, find the values for m for which the roots are real. Well, the only way the roots could be real is if m squared minus 4m minus 12 is greater than or equal to 0. That's the only way they could be real. But they further go on to say they should be unequal. So I don't want it to be equal to 0, because for equal to 0, I just simply have y equals 2 minus m over 8. And that would be one solution to the problem, by the way. So I'm going to erase this over here and say I want this to be a strict inequality. And then I'm going to solve this thing by the techniques that I've been taught in pre-calculus. I'm hoping it's nicely factorable. It looks like it is 6 and 2. Let me just check it. That gives you m squared. Yeah, you get minus 4m, and you do get minus 12. Number line goes down. On the number line, I put two numbers, minus 2 and a 6. And I would test those intervals out, and there's 3 of them. A number after 6, like 7, plug it in. And again, when we plug it in, we're plugging it in here. And we're trying to make sure it satisfies that inequality. And 7 would, because you have positive on positive, and a positive on positive definitely greater than 0. If I took a number between minus 2 and 6, like, I don't know, 0, plugged it in, you get a negative times a positive, which is negative, and that's not greater than 0. Now, if you go below minus 2, like you take minus 3, plug it in, you get negative times a negative, which is a positive. So this gets shaded in. So I'm going to write down that this is minus infinity up to minus 2, union 6 off to infinity. And this is what m is. If you want to write it as an inequality, you would say m is less than minus 2, or the m is greater than 6. And you can write it either way, by the way. Thank you.